want to thank everybody for joining in on this webinar. I hope you get some useful information out of it. I'll go through a presentation and then we'll have a question and answer at the end. So we'll go ahead and get started. My name is Chris Close. I'm the presenter today. I'm the Business Development Manager at Jeffrey Rader. Jeffrey Rader has been designing material handling systems, many of which have to do with wood chips and biomass. Been designing those systems for around 50 years. I should say designing and supplying equipment for systems for around 50 years. Our headquarters is located in Duncan, South Carolina, which is near Greenville, South Carolina, to give you an idea of where we are. Personally, I've been working in this business for about 30 years, designing and selling material handling systems for pulp and paper, the power industry, and I did a stint in the marine industry as well. I think I sold my first boiler fuel feed system in 1983, so that might be kind of a sad statement, but at the same time I've had a lot of experience in selling these types of systems. We're going to mute all the lines now so you can carry on conversations. You'll be muted until the end of the presentation. You can submit questions through the Q&A feature of the program, and we'll talk about those. We hope to have an open discussion at the end, so we'll try to hope you have a lot of questions, and at the same time we'll try to have that open discussion at the end. And this presentation is being recorded. It's going to be, I guess, posted on YouTube or something, so it's being recorded, so watch what you say. So the first thing I'll talk about is biomass and what is biomass. The reason I bring this up is because having worked primarily with woody biomass myself, I'm generally feel like I've kind of got the blinders on. When anybody says biomass, I immediately think about woody biomass, but there's a lot of other biomass fuels out there. The traditional ones that I think about are woody biomass, as you see here, or in this form, more the type of bark material that you see around in fuel yards. But there are other materials that are being widely used as fuel as well, and some of those are bamboo is an example. Straw is big in other parts of the world. Corn stover is also a big one here in the States. So biomass is a general term, and we just need to keep in mind that as far as biomass handling systems are concerned, the fuels can be quite varied. They have very different characteristics, and have to just keep that in mind. At the end of the day, we'd like to have products like you see across the bottom of this slide, which are very uniform, consistent moisture, near-size products that we actually introduce into the boiler, but we all know that that's not the case. Originally, when I was putting this presentation together, I was thinking about boiler fuel handling, and the first thing that came to mind was the actual boiler feed at the boiler front. But as I got to thinking about it more and more, there's a lot more that goes into a biomass fuel handling system, and this is an example of one here. And every biomass fuel handling system will have these elements associated with it. There's a receiving area where the trucks come in and are unloaded. There's generally a processing area where we do some screening or size reduction or some sort of processing to the fuel. A storage and reclaim area, which could be anywhere from 3 to 30 days of storage according to who you talk to. And then there's actually the boiler feed in the boiler house. So the systems are quite large, and do have quite a bit of equipment associated with them. So we'll talk a little bit about just the biomass fuel handling system in general, but then we'll get more specific and talk about the different types of boiler feed systems that you can have actually in the boiler house itself. Should also say that this particular system that you're looking at here is a project that we're working on now. Jeffrey Rader's working on now. It's a woody biomass fuel handling system for a 50 megawatt electric generating station. It's going to go into service in 2014. And although this is a biomass fuel to electric generating station, as far as the process at the end of the system, the fuel handling system, we could as well be feeding a pelletizing plant. We could be feeding a district heating plant. We could be feeding a gasifier, or we could be providing process material to even a torrefication process. So this outside material that you see, hold on a second. Is that what I'm looking for? Yeah. Technical difficulties. Hold on. How do I get over here? I want to get to mine. Okay. Well, I guess I'll move on then. Moving on, let's talk about process flow, and in this I just wanted to go into detail a little bit more about the process flow as far as Jeffrey Rader equipment is concerned. And if we go back to the receiving area, as the trucks come in, generally they'll be weighed, so there'll be a truck scale incorporated into the system. The trucks are unloaded. In this case, we're showing a hydraulic truck dumper. In the processing area, we'll typically do some type of screening to remove unwanted material from the flow, in this case, oversized material. It'd be a size reduction equipment, in this case, a wood hog, so we're taking oversized material and processing it down to an acceptable size so that it can be handled by the fuel handling system and the boiler. Because of the environmental restrictions that we have today, oftentimes now we're asked to put on telescopic spouts onto our conveyor systems. Just another complication in the system. This is not something that we typically supply, or that we manufacture, but that is becoming more and more of a critical element in a typical system. In this case, manual movement of material around the pile to either stock the material out or bring it back to the reclaim system, or to rotate the pile based on where they are in the process. Open air, in this case, this particular plant has an open air storage pile, which is kind of an example there of how that works. It's usually in as close a proximity to the boiler as possible, but limited by the conveyor system that feeds from the open air storage pile to the plant. And then a reclaim system. In this case, we used underpile traveling screw reclaimers to automate a portion of the pile. As you can see, we didn't automate the whole pile. That would have been too costly, but we were able to automate a portion of it so that there were hours of storage available, readily available to the operators of the power plant. And then last but not least, the boiler feed system in the boiler house itself, on the face of the boiler. So the system then would comprise the equipment plus the conveyor systems, and in this case, it was our responsibility to complete system. At the bottom, again, an illustration of a complete system: receiving, processing, storage, and reclaim up to the boiler feed. And I just wanted to briefly go through proprietary equipment that Jeffrey Rader supplies in a typical system. So truck dumpers, the receiving station, kind of talk about these in different pieces of equipment because you can have just a truck dumper, or you can have a truck dumper with a receiving system, or you can have just a receiving system based on the type of trucks that you're receiving. Again, screening and oversize reduction. Jeffrey Rader has been an innovator of equipment over the years. We've got about 500 patents on different types of equipment. Our emphasis or focus over the years has primarily been the wood products industry. So our equipment in general is designed specifically for that. And we have designed a bucket elevator, not that we use them in all processes, but they do lend themselves to certain plant applications where belt conveyors are not applicable. And our bucket elevators are designed specifically for wood products. It's important to keep in mind. Storage and reclaim, different configurations. We just are showing here a circular silo with a traveling screw reclaimer in the bottom. Pneumatic systems, not something that would always be used, but again, because of plant configurations and maybe difficult routing with other types of mechanical belt conveyors, chain conveyors, etc., a pneumatic system might solve a problem for you that is not solvable with a belt conveyor or a chain conveyor. And then the boiler feed system itself. So these are all proprietary equipment that Jeffrey Rader can supply in a system. The application, the type of performance you're trying to get out of the equipment, or in certain cases, customer preference, we can install other types of equipment. For instance, we could use walking floor trailers as part of our receiving system, have that the walking floor trailers dump into a receiving hopper. We can use gyratory screens instead of disc screens if we're trying to remove sand and grit as well as oversized material. We can use solid rotor hogs instead of swing hammer hogs, as we have, based on, as an example, if we're processing corn stover instead of wood, waste wood, we'd have to use a different type of size reduction equipment. And then we might choose to use a stacker reclaimer instead of under pile screw reclaimers. So any of those various combinations of equipment can be used, and we can design a system with those various pieces of equipment included. Within the Forest Products group, we have assembled an engineering group who is responsible for putting together systems. They are a small but knowledgeable group. Most of their experience comes with either the consulting companies or material handling equipment suppliers around the country. They have a wide range of experience, not only with wood products, but also with coal and mining and mineral applications. So they're available to help us put systems together and come up with solutions for problems that we may encounter along the way. So if we talk about, now we're going to talk more specifically about the biomass fuel feed systems at the boiler, and we'll spend the rest of the time talking about boiler fuel feed systems in the boiler house and what goes into the design of a system. Our experience, well, first of all, let's go through different types of systems. Mechanical feed systems, which generally are optimized for biomass or other diverse alternative fuels, and pneumatic injection systems. We have done both. Rader has a very long history of doing pneumatic conveying systems, so this was a natural for us. The pneumatic injection systems have been used primarily on co-firing or 100% conversion type projects. The mechanical feed systems generally are feeding either to grate style boilers or more recently fluid bed boilers for burning biomass and alternative fuels. Pneumatic systems, as I said, have been used for co-firing of biomass fuels for pulverized coal boilers, where we have to get the fuel down to a very small size and the fuel will be burned in suspension. We'll talk about those a little bit more. Our experience, I think what we kind of bring to the table as far as designing systems is our overall material handling experience, and really more about understanding the fuel and the characteristics of the fuel as more, or at least as much as, the particular design of the components within the system. There is no one size fits all for biomass. Every system is unique and different. They look the same, but they aren't. Things that need to be taken into account are the source of the biomass. Is it mill produced? Are you purchasing the fuel from an outside source? Is it hardwood? Is it softwood? Is it C&D waste? Is it agricultural waste like corn stover or straw? What is the moisture content? Is it wet? Is it dry? Is it wet part of the year, dry part of the year, based on where it comes from? The climate, is it a wet climate, a dry climate? Is it hot or cold? The process equipment upstream, is it on-site where you have full control of it and can therefore control the quality of the biomass fuel? Or is it an off-site processing facility somewhere where you really don't have control of it? And in that case, your system has to be capable probably of handling a wider range of fuels. Also, the accuracy of the feed rate to the boiler. Is your boiler a base load boiler or is it a peaking plant? We've had situations where we had to design the system to handle those parameters. And in closing on that note, probably the most important thing for us is the number of systems we've installed, and probably more important, the number of systems we've started up. Because as you go through the startup process, you learn something every single time, and that I think is where probably the value added is for Jeffrey Rader. So if we look at mechanical feed systems, we're going to look at two different types: live bottom bins. And this is a typical example of a boiler house system. In the illustration, the boiler is on the on the left-hand side. And in this case, the live bottom bin is up in the boiler works. And this is a typical example of a live bottom bin. That live bottom bin is fitted with a number of metering screws. Could be one or two, or I think I've seen live bottom bins with as many as probably 24 screws, feeding a fairly large boiler that may have 8 feed spouts on that boiler. I'm going to stop here for a second because I want to be able to, I've got to do something here. How do I get my pointer, which is over here? Can't get over any farther. The pointer, yeah. Oh, okay, yeah. Okay, thank you. Boiler is here, steel structure is here, live bottom bin. In this area here, almost all systems will have slide gate valves to isolate the boiler, the furnace from the fuel system. And I've shown a couple of examples here, a pneumatically operated valve or a manual valve. These would be used either individually or in combination, and would typically be down in this area here to isolate the boiler, either in the case of an upset condition in the furnace, an overpressurization in the furnace, or if there's going to be maintenance done on the fuel feed system and the furnace is still hot, you can isolate the system from the fuel handling system from the furnace. And then for thermal expansion, again in this area here, generally the boiler is the furnace is allowed to grow up or down based on the differential heat, but the boiler feed system will be rigidly mounted within the structure, so expansion joints of this type would be located in this area here to allow for thermal expansion of the system. Okay, a little bit more about the live bottom bin specifically. This is one that we recently supplied. This is what we feel like is an optimal design based on what we've come up with and based on our experience. I'll talk a little bit about it. Of course, the bin would have negative slope walls for most biomass materials, and we would be careful in our design in the width to height ratio of the fuel system, of the fuel stored in the bin, in order to ensure that we get good flow through the bin. You can see that in this case we have a separate trough from the bin, so it's not the old traditional flat floor design with screws above that flat floor. We feel like there's some features and benefits of doing this as opposed to having the screws mounted over a flat floor. The screws themselves, we spent a lot of time designing the screws and trying to optimize the screws for good flowability through the bin. We've all probably had experiences where we've encountered bridging the material in the bins, and really, from our perspective, that all comes about due to the proper design of the screws, and more specifically, the drawdown of material that goes along with that proper design of the screws. And although it's difficult to see in these pictures, we do use a combination of progressive pitch and a conical pipe design, those two things used in conjunction with one another in order to be able to basically just promote flow through the bin. And then materials of construction. The biomass fuels are typically very abrasive, and we have a philosophy at Jeffrey Rader where we try to get 2 years minimum life out of our equipment. And in order to do that, along with the design, materials of construction we're using, trying to use where it's economically feasible. We're trying to use chromium carbide overlays. We're using chromium carbide on the periphery of the flights, difficult to see in these pictures. And in this case, we also used ceramic coatings on the pipe in order to protect the pipe against wear. Again, always trying to maintain that 2-year minimum wear life. Something that's a little bit subtle in these pictures, but you can see it here, in certain cases, we've adopted a design where we're using half pipes between the screw troughs. And at first glance, you might say, well, that's just going to be an immediate problem, and you're going to encounter bridging with that. But we've actually found that the opposite is true. If you have a proper design of the screws, if you're promoting good flow through the bin, and in addition using these half pipes, which by the way are stainless, you can increase the size of the bin for a given number of screws, so your storage volume is greater. And in certain cases where the volume, the reclaim volume or reclaim rate from the bin is such that you can accomplish that with one screw, you can decrease the number of moving parts, and therefore your replacement parts cost, your total consumed horsepower, number of drives, etc., is all decreased and optimized based on using fewer components. So basically all these features, although they're somewhat subtle, I think a lot of people would look at a screw and basically say a screw is a screw, but there's a lot of subtle features that go into the design of our equipment, and they all add up to a better performance, better runnability, availability, and longer life of the system for the end user. The other type of system, mechanical feed system, that we have been supplying over the last 10 or 15 years is what we call the European system. I think this design generally was developed in Scandinavia 15 or 20 years ago, and is generally designed for the sole purpose of being able to handle a wider range of biomass fuels. If you have a very consistent biomass fuel, and you can depend on it being consistent at all times, the live bottom bin is certainly the way to go. If you either know up front or you expect down the line to have an ever-changing fuel source, then this system probably is more suited to and better able to handle a wider variety of material. If we go through the systems, there is a day bin. In this case, we're showing 2 in this particular case. That would generally be somewhere between 30 minutes and an hour of storage at the face of the boiler. That has a traveling screw reclaimer in the bottom of it, so rather than depending on gravity feed down to the screws, the screw is actually traveling around and attacking the material, if you will. So gravity does not, it comes into play, but it's not the only way of material finding its way down to the screws. From there, the material is metered out onto a chain conveyor, and then based on the number of spouts you have, we'll use what we call robbing screws, or again, the term metering screws could be used. And in that case, we're metering out a percentage of the flow in the drag chain conveyor, metering out equal percentages going down to these feed chutes. Again, you'd have slide gate valves and expansion joints. And in the case of fluid bed boilers, you would have rotary airlocks, which would be incorporated into the system to be able to maintain pressure in a positive or negative, a positive pressure in the boiler in an atmospheric condition in the rest of the boiler fuel feed system. The couple of disadvantages with this type of system is it is a one-line system. So in the case of feeding these 3 spouts, we have a one-line system here and here, feeding material to 3 spouts. So that could be perceived as a disadvantage. If we lose this reclaimer or this drag chain for any reason, and of course we'll lose fuel feed to these three lines. We can design systems where you have crossovers and so forth. It's an extra level of complication to the system. We can also oversize the system so that if this system were down, this system could pick up from a capacity standpoint, and we could feed more fuel in through these fuel feed points to compensate for the loss of fuel through these fuel feed points. So that's possible. The other problem that we have in today's climate is that the cost of these systems is higher. So there is a trade-off. The live bottom bin, without a doubt, is less cost than these European systems, but it does have some disadvantages. If we look a little more specifically at those same components, this illustrates the same one half of what you saw in the previous slide. Day bin, reclaimer, well, the silo and the screw reclaimer here, which in this illustration or in picture is here and here. This is a dual system, but this represents the same type of silo and reclaimer. The chain conveyor here and the robbing screws here. Here's the chain conveyor feeding a number of robbing screws, and then you see the robbing screw here. So as an example, if we've got a 60-ton an hour system or 60 tons an hour of biomass fuel coming in here and here, then we'd split that based on the speed of these screws. We'd split that 60 tons into 20, 20, and 20. And then the rotary airlocks, as we said before, here, here, and here, to airlock the boiler from the boiler fuel feed system. And then slide gates and expansion joints, which this is a stack up on a job we did. This is actually the pneumatic valve here, which the boiler conditions dictated whether that valve was open or closed. There was an overpressurization in the boiler, and this valve would automatically close based on a pressure-sensitive switch. And then this is a manual gate valve for safety. And then here's the expansion joint down here. Moving on to the pneumatic feed. This is an example from a plant in the UK. This is RWE, which is one of the larger power companies in Europe. This particular plant is at Aberthaw, South Wales. And this system was actually put in to supply, on a heat input basis, 20% of the heat input to a coal-fired boiler. It's a tangentially fired boiler, and the system was all put in after the fact to fire up to 20% of biomass. Now, the fuel in this particular case is green, woody biomass, 25% moisture on average, and a material size of about 4 millimeters. And so there is some size reduction over a typical biomass system for co-firing, and that the fuel has to be sized for suspension firing. The beauty of this system is its flexibility. The pneumatic conveying system, as you can see here, we're going up over buildings and into an existing coal-fired power plant. So the flexibility of conveying pneumatically is one of the main advantages here. The storage facility, you see the storage silo here. This represents probably a day's worth of a biomass storage. In this particular case, there's a processing area here, which this is typical green wood chips in the silo. In here, we're using fine grinders, hammer mills, basically, to size the material down to 4 millimeters or less. And then we're also metering in this area. So the demand of the boiler at any given time is, the fuel is metered out from this area here into the pneumatic system. If you turn around and look the other way, these are the conveyor lines running across the boiler house. You can see that there's actually buildings here. So to do this with mechanical conveyors would have been very difficult, but to do it with pneumatics is really pretty easy, because we're able to fly across the top of these existing structures and then into the boiler house here. And then actually the injection at the four corners of the furnace, again, if you were trying to do this mechanically, that would be fairly difficult, but in this case we have, I think these are 12-inch lines, I'm not 100% sure about that, but basically we come across and into the boiler house, and then the only thing we have to be concerned about is routing 4 lines through the existing boiler house in order to get to the 4 corners of the boiler. A typical pneumatic injection system will have a positive displacement blower in the case of a Jeffrey Rader system, with an example here. Now these can be quite large, but typically because you're handling a relatively small amount of material, 20 tons an hour or less, the blowers and the drive motors are not that large. This represents a fairly large system here. In a lot of cases today, again for environmental and personnel reasons, the blowers will be in these soundproof enclosures. So the blower and motor, as you see here, will be enclosed in these soundproof enclosures. The fuel is metered into a rotary airlock feeder and then down into the pneumatic line here. This is the air side, this is the product side. So the metering is done here. The rotary airlock is just an airlock, it's not doing any metering. And then the air and material mix here, and then it's conveyed on down the line. And then again the injection system at the boiler. You can see we've got shut-off valves. So all those same, the same type of shut-off valves are used that you have in a mechanical system. They're just introduced into the product line instead of into the chute work. Got some case studies. Unfortunately, I don't have any live bottom bins. We've sold some recently, but they're either being installed or we don't have pictures yet. So unfortunately, I don't have any pictures of live bottom bins to show you, but I do have some other systems that we've supplied in the last several years. This is an example of a European type system. I'll just give a couple of highlights of what these were. This was, our client in this particular case was Foster Wheeler, the boiler supplier. This was supplied to Virginia City, to the Virginia City Energy Center up in Virginia. Our scope of supply was the biomass boiler fuel system, which was 20%. Again, on a heat input basis, we're supplying 20% of the fuel is biomass, 80% is coal. This system, based on fuel availability, will either run on a continuous basis or maybe run seasonally. And we supplied 4 basically identical systems, 2 on the front. There's 2 boilers in this particular case, so there's 2 systems feeding each boiler, one on the front side and one on the back side of the CFB boiler. And our scope was the silos, as we showed before, the drag chain conveyors, the metering screws under those drag chains, the rotary airlocks, again because we have a CFB boiler running at positive pressure, expansion joints, and the manual and the pneumatic shutoff valves. This is another example, in this case a European system. This is at a paper mill. This was our customer in this particular case was Caverner Power, supplying the equipment to Georgia Pacific. The system is down in, the plant is down in Louisiana. This again is a circular silo with a traveling screw reclaimer, chain conveyor. In this case, only 2 feed points on the boiler. This boiler is co-firing woody biomass and coke, pet coke. And this, they've told us at this particular plant that being able to burn woody biomass in this particular case is very important to their bottom line because of the energy savings that's associated with that. Another European-style system. This was we supplied to Interstate Paper in Riceboro. We actually did the concept design for this project. This particular customer was having trouble. He had a conventional multiple live bottom bins feeding the spouts, fuel spouts on the boiler. They changed their fuel sourcing. They're producing actually mill-produced fuel, but also started to buy a lot more purchased fuel. And when they did that, the consistency of the fuel that they were buying changed. And the live bottom bin system that they had could not handle the variations in the fuel that they were seeing. It was a combination of fuel size, moisture content, and the actual equipment that was used to process the wood fuel that was being purchased and brought in from the outside. In this case, we supplied 2 silos with traveling screw reclaimers, metering bins and screws feeding the boiler fuel spouts. And since the time this was put in, it has solved their problems, and they are able to accommodate the variety of fuels that they get, and have had very few problems with the boiler since the system was put in. Another system. This is a system that we supplied in South Korea. It's for a paper company. It is both a pneumatic fuel handling system as well as a European-style system. The pneumatic part is from the fuel yard, which is across the plant. And again, in order to be cost-effective and to come up with a conveying solution that works for them, we used pneumatic conveying from the fuel yard across the plant to the boiler house. We feed into a European-style fuel system in the boiler house itself. And again, because of the variety of fuels that they have at this particular plant, the European-style system made more sense. They're handling paper waste, waste plastic. It's a recycled paper mill, so they're handling rejects from the recycled paper that comes in. They're handling a couple different types of sludge, and then a couple different types of biomass fuel. Some of it C&D waste and some of it typical hog fuel or hog bark. So our scope again for this was the pneumatic conveying system, and the 2 circular silos with the traveling screw reclaimers. In this case, instead of drag chain conveyors, screw conveyors, to do the conveying from the silos alongside each side of the boiler, and then robbing screws and the fuel feed spouts, including expansion joints and isolation valves and so forth. I just did not include rotary airlock valves because this boiler operates at a slight negative pressure, so rotary airlocks in this particular case weren't required. And I think this is the last one. Some of you may have heard of the DRAX project. It's been ongoing over in the UK for quite a few years. We were involved in the first 2 phases of that project. This is an illustration of the system that was installed to get them up to a co-firing rate of 10% of the total that was required. In this particular case, we're handling milled wood pellets. The product size is very small, I think 99% less than 1 millimeter. But the key here was to be able to provide an even and consistent feed to the boiler, so the rate was consistent. There could have been issues with flame stability if the fuel feed was irregular. So one of our main objectives here was to be able to supply a very uniform feed to the boilers. There actually are 6 boilers in this particular plant. We were feeding 24 burners on those 6 boilers, and in that case we had individual lines feeding individual burners. We have since have a new technology and a capability to be able to split pneumatic lines and to do a predictable and adjustable split of fuel in a pneumatic line. So now, in a similar case to this, we could have possibly used 12 pneumatic systems feeding the 24 burners, or in certain cases even 6 main feed lines that would be split twice, feeding those 24 burners. So therefore, we'd have less equipment involved in the system. Well, I did have one more. No. Okay, so that's the end of the presentation. If you have questions and answers, we'll open it up for that now.
Chris, we did get one question submitted through the Q&A feature.
Okay.
And it says, what are the advantages to the silo-style storage bins?
Okay. Presume in this case you're talking about the round silos, and the main advantage is the reclaiming device in the bottom. The reclaim device is traveling around the bottom of the bin, so instead of depending on gravity to feed material down to the reclaim device, we're actually moving in a horizontal direction into the fuel. So there's less possibility for bridging, and basically it will handle a much wider range of materials. So whether the moisture content changes, the size of the material changes, the round silos with the traveling screw reclaimer in the bottom are going to be more successful in being able to reclaim consistently and evenly the material, a wider range of materials.
What do they mean by traveling screw in the bottom? Is actually
It's a swivel.
a swivel stick?
Yeah, I think
Oh,
it's
okay.
traveling.
Then they have the swivel stick, and then they have the outfeed.
Yeah, then they. I guess the one thing I didn't understand is on the European style, how you keep the last one full unless you
Overfill.
fill and drag it back.
Drag it
I'm
back.
sure you're, I think you're probably doing some kind of demand check, keeping that last one full,
Yeah.
and then,
Increasing or decreasing the speed of that.
I've seen those
Okay.
worked that way. As a matter of fact, that's what they do at Toledo.
Okay.
They had originally, they returned,
Yeah.
and then they stopped doing that, so.
The system controls capability that we have today over 20 years ago, or even 15 years ago, is such that you can maintain a flow or maintain a level much more consistently and precisely than you could years ago. The systems, you're exactly right. The systems 20 years ago did have an overfeed feature, which added some complexity to that design. But you did generally either overfeed back out of the boiler house and down to a recirculation pile, or in some cases you recirculated material back around to the top, either the in-feed conveyor or back into the top of the silo. With the systems that we have available to us today to control the rates, we can control the rate precisely according to the demand of the boiler, and almost guarantee that the, I don't know if I have a, I want to go back to a case study here that just to remind you about. In this particular case, one of the problems that they had was the irregular feed to the boiler, which was causing upset conditions in the furnace to the point that it was affecting the emissions, and they were, I'm trying to say, they were emitting more particulate than they were supposed to and than that they were allowed to. This is actually at a plant that's a bit unique, I think, in that they use this boiler as the, not as the base load, but this boiler in this particular plant carries, handles the peaks in the steam header going to the paper mill. So it has to be capable of increasing and decreasing based on header pressure, and in this case it does, the level fluctuates in the metering bin, which is the, look here, you look at this view here, you can see that there is a bin over the screw that is feeding the feed chute. And there is a slight variation of level in that bin. It's about a 5-foot tall bin, and we can maintain within a couple feet, a foot plus or minus, the level in that small metering bin based on the requirements of the boiler. So today, with the control features and capability that we have, we don't need to have that recirculation leg that we used to have years ago. Any more questions?
No?
Okay, if there's no more questions, thank you for your time. I appreciate you listening to our webinar and sitting in. Hopefully it was of some benefit to you. If you can, if you have any questions that come up, you can get in touch with me. My contact information was on that opening slide. And we appreciate your time and interest, and we'll be having more of these webinars, so hopefully you can attend those as well.